Today we are going to discuss about the current division rule, voltage division rule, thereafter source transformation technique. Okay. Now first see the current division rule. In the case of current division rule, it is used to determine the current through one particular element. That means current through either R1 or current through R2. That means if you want to determine the current through any one particular element, when the elements are connected parallel, in that case, this current division will be useful. Okay. Now how to determine this current through one element by using current division rule. Now see here. Now R1, R2 both are connected in parallel. Now these two are also connected in parallel with the supply voltage. Okay. Now I am assuming that current through supply is total current and current through R1 is I1, current through R2 is I2. Okay. Now voltage across R1 also Vs. Why? Because in the case of parallel connection, voltage across all the elements are same. So here R1, this R1 and Vs both are connected parallel. So that is the reason why voltage across R1 is nothing but Vs. Okay. By using Ohm's law, we can write this I1 is equal to Vs by R1. Why? Because voltage across this one is, we know that Vs. Okay. Now I1 is equal to Vs by R1. That is what I written here. Okay. Similarly, R2 is in parallel with Vc. Now we know that voltage across R2 is Vs. Okay. From that we can write I2 is equal to Vs by R2. That is what I written here. Okay. This is the equation for I1 as well as I2. Okay. Now I want to determine the total current. Now total current is equal to total voltage by total resistance. Now Vs is the total voltage. Then what is the total resistance? So here these two are connected parallel. Now it will become R1 R2 by R1 plus R2. Okay. Now here Vs by R1 R2 by R1 plus R2 means it will comes under like this. Okay. Now Vs into R1 R2 R1 plus R2 by R1 plus R1 R2. Sorry. Okay. Vs by RT and now RT is R1 R2 by R1 plus R2. Now this here into substitute R1 R2 by R1 plus R2. Okay. After that, you will get this equation. If you solve the equation, you will get like this. Okay. Vs into R1 R1 plus R2 by R1 R2. Okay. Now I want to determine I1. Now here I1 is equal to, now substitute Vs equation here. Now what will happen to Vs, and Vs is given by Vs is equal to I total into R1 R2 by R1 plus R2. Substitute that Vs value here. Okay. Simply write the Vs equation from this. Okay. Vs is equal to I total into R1 R2 by R1 plus R2. Okay. Thereafter substitute that Vs in this equation. Then you will get I1 is equal to total current into R2 by R1 plus R2. Similarly, substitute this Vs here. Then you will get I2 is equal to total current into opposite resistance by the total resistance. Okay. Now this is about current division rule. Now if you observe the voltage division rule, when it is useful, if you want to determine the voltage across one particular element, then we are going to use this voltage division rule. Okay. For that, I want to determine the total current. Now, by using Ohm's law, I is equal to Vs by R1 plus R2 plus R3. Why? Because here these three are connected series. Why? Because whatever the current present in the R1, same current is flowing to the R2, same current is flowing to the R3. Okay. Now R1 plus R2 plus R3 total resistance. Now I is equal to total voltage by total resistance. Okay. Now here we can write the voltage across R1 as V is equal to I into R1. Similarly, voltage across R2 as I into R2. Similarly, voltage across R3 as V is equal to I into R3. Okay. Now substitute this I value, case 1, case 2, and case 3. Now here VR1 is equal to I value is given by Vs by R1 plus R2 plus R3 into R1. Similarly, VR2, similarly, VR3. Okay, that means total voltage into same resistance by the total resistance. Our requirement is voltage across R1. Now this will become same resistance. Now total voltage into same resistance by the R1 plus R2 plus R2. That is total resistance. This is about voltage division rule. Now next one is source transformation technique. Okay. Now in the case of source transformation technique, we are going to convert voltage source to current source and current source to voltage source. Now first see the voltage source to current source. Now if you want to convert voltage source to current source, initially for the original circuit, voltage source must be connected in series with the resistance like this. Now see here, source voltage, this is connected in series with the some resistance RV. Okay, after conversion, current source is connected in parallel with the resistance. That means this circuit equivalent this circuit. That means we can replace this circuit with this circuit. Okay, after replacing here, current source is connected in parallel with the resistance. Then what is the value of current source? And by using Ohm's law, I is equal to this voltage by this resistance. Okay, this voltage by this resistance. That means Vs by Rv. If it is 5, this is 5. It will become 5 by 5. It is 1. If it is 10, if it is 5, then 10 by 5, it will become 2 amps. Okay, like that we need to replace the current value. Similarly, here same resistance we need to replace here. That means if it is Rv, here also Rv. If it is 20, here also 20. If it is 100, here also 100. Now this is the voltage source to current source. Okay. Similarly, we can solve for current source to voltage source also. Now here, this is the original circuit. That means current source is connected in parallel with the resistance. Okay. Now this is the original circuit. After conversion, voltage source is connected in series with the resistance. Okay. That means we can replace this circuit with this circuit. After replacing, what is the value of voltage? By using Ohm's law, V is equal to I into R. That means this current into this resistance. If it is 10, this is also 10. It will become 10 into 10. Now voltage is 100. If it is 5, if it is 2, then 5 into 2, it will become 10. Like that we can replace. Okay. Thereafter, same voltage we need to replace here. If it is 100, this is also 100. If it is 500, this is also 500. Okay. Now this is current source, voltage source, as well as voltage source to current source. Okay. Thank you.